Alright, welcome to the video for the Unit 4 practice test. I congratulate you for deciding to spend the time to watch this video. I know it will help you if you think carefully about what is presented. Alright, first thing we're going to do is give you the answers to the first 10 problems. In fact, if you haven't worked out the practice test as much as you can by yourself, alone, I would do that. I would turn this video off and work out as many as you can, and then come back to the video and see which ones you got right and which ones you need help on, and then watch the video. You'll do way better on the next test if you try the problems first. But anyway, on the screen now is laid out the answers for the first 10 problems. So pause the video so you can check your answers. Up next, we will take a look at the next group of answers. Alright, here's numbers 11 through 16. Once again, if you need more time to check your answers, which I'm sure you will, go ahead and pause the video and you can check your own answers. Problem number 17 isn't laid out on the screen, but it's one of those problems that's not easy to answer just by writing it, so you should just watch the video for that one to check your own answers. Alright, up next we'll go over each problem one by one and explain how you get the answer for a problem that is like that, so you're ready for the ones on the test. Alright, here's the first problem. It asks us to find all the angle measures in this triangle, and we can see they've given us algebraic expressions for each one of these angles. And really the secret to working this problem out is just remembering that all three interior angles in any triangle, the measures add up to how much? 180 degrees. That is called the triangle sum theorem. So I just have to take these three angle measures, the 4x plus 20 degrees, the 3x minus 8 degrees, and the 5x, and they don't call it the triangle sum theorem for nothing. We're just going to add those three angle measures together. Alright, now that we have our equation, we can work on solving it. So my first step would be to combine all of the like terms. 4x and 3x make 7x plus 5 more x's would be 12x, and a positive 20 and a negative 8 would add up to positive 12 degrees, and that still all equals 180. If I add 12 to both sides, 12x will equal, excuse me, I'm not going to add 12, I'm going to subtract 12. That would give me 168 degrees. Obviously, if I were working this problem on a real test, I would take the time to carefully work this out. But I would divide both of these by 12. Let's actually give you a little reminder how you would do that division. You really don't have to divide the 12 all the way into the 168. You can simply take the 12 into the 16. And how many 12s would fit into that 16? Well, it would go exactly once. And 1 times 12 would be 12. Subtracting would leave me with 4, and I'll bring down my 8. How many 12s go into 48? That one's actually on the multiplication table. It would go 4 times. Oops. It would go, well, looks like this is having a little bit of a problem. There we go. And 4 times 12 gives me 48 with no remainder, so x is equal to 14. Alright, except that's what x equals. What they really want are the angle measures. And I can simply find that by plugging the 14 into each one of these. So 4 times 14 comes out to be 56 degrees, and then when I add on 20, I'll get 76 degrees. 5 times 14 comes out to be 70 degrees. 3 times 14 would be 42. Take away 8 leaves me with 34 degrees. And now I can figure out which one's the smallest. There's the smallest. It's 34 degrees. And then the middle angle would be 70 degrees, and the largest angle would be 76 degrees. Okay, so you just have to remember the interior angles for any triangle have the sum of 180 degrees. Alright, here's number 2. They ask us which of the following sets of angle measures could form a triangle. In other words, well, what do we know about the angles in a triangle? They have to have the sum that equals 180 degrees. So if any of these do have that sum, then they could be a set of angles for a triangle. And if they don't, they can't. So if you add up 33, 67, and 103, it all adds up to 203 degrees. So that's a big fat no, because that's not 180. 45 and 45 make 90, and another 90 does make 180 degrees. So that's a big Yes, that could be. 20 and 60 make 80, and 110 more makes 190. So that's no, that's not 180. And 36, 54, and 80 all adds up to 170. And that's a big fat no. So the only set would be this. Okay, and on the test, this is a choose all that apply problem. And so if there's more than one that adds up to 180, you would choose all of them that do. Okay, and you should just like carefully add. You know, obviously if you made a mistake with your adding, it would throw off your answer. So be careful when you're doing your adding. All right, problem number 3 looks a lot like one of these problems where we would normally prove whether the triangles are congruent or not, except it's a multiple choice question, or it will be on the test. And so you don't have to do that, but you do have to figure out which theorem or postulate could be used to prove that the triangle on the left is perfectly congruent to the triangle on the right. All right, and maybe before we start this problem, let's talk about the ones you need to know that actually work to prove two triangles are congruent. So one of them is called side, side, side. Another one's called side, angle, side. And another one's called angle, side, angle. Those are the three that you need to know about that do work to prove two triangles are congruent. Well, there's some that, for lack of a better word, don't work. In other words, these things can match in a triangle, but the triangles can still be different. And one of those is called angle, angle, angle. And another one is called side, side, angle. It's almost a little joke in geometry classes to always spell it that way. You might be tempted to write ASS, but please don't. Okay, so what if you were able to prove one of these? Would that guarantee that the two triangles are really congruent to each other? No. That's what we mean by don't work. These things could match, but the triangles still could be different. So here's the big key to this problem. It says, hint, mark your diagram with the given information. So here's our given information. Let's see if we can mark it up. So first of all, they tell me that segment MQ and PN are parallel. So make sure you don't put tick marks. Those are parallel, and you've probably done enough of these problems to know that around parallel lines we can get congruent angles, like alternating interior angles or corresponding angles. So we'll probably use that for something like that a little bit later. Excuse me. Then they tell us that segment QR, that's this one, is congruent to segment RP. So those are congruent. So let's see. Let's kind of cross these out. We're not going to think about those. So I do have a pair of congruent sides. And couldn't I use vertical angles right here to prove those two angles are congruent? Here's maybe what's nice. We don't have to do a proof. We can just say, yeah, well, yeah, I'll get congruent angles there. And then finally, let me see if I can actually make this stand out. If you think about these being parallel lines and this being a transversal, hopefully that makes it look a little bit more like the drawings we were doing back in Unit 3. How about this angle here and this angle here? Can you see that those are alternating interior angles, and that would give us another pair of congruent angles? So if I just look at one of these triangles, do you notice, do I really have angle side angle? Well, to have angle side angle, the side has to be right between the two angles. And do you notice it is? It is right between the two angles. So we could prove this using angle side angle. And if you will just mark up the figure and kind of use what you know from geometry, you should be able to figure a problem like that out. Not marking the diagram makes this a total guess job. So mark up the diagram. All right, here is problem number 4, and right up here they tell us that we've got triangle PQR, and they give us this important piece of information. And like all important pieces of information in geometry, the more we can mark up our triangle so we can see what's going on, the easier things get. So this segment PQ and this segment PR are congruent. And we all know in geometry we can mark segments congruent using tick marks. So I'm going to mark those two segments congruent. They also tell me that the measure of angle P, that's this angle right here, is 70 degrees. So I'll fill that in. And they want us to figure out the measure of angle Q and the measure of angle R. All right, so clearly I hope you can see that we have an isosceles triangle where two sides are congruent and then this segment QR is not. So one of the theorems we learned in this unit is something called the base angles theorem. Basically says if two sides of a triangle are congruent, then two of its angles are congruent. And which two? The two that are straight across from the two sides that are congruent. Okay, in other words, these have to be exactly the same. The base angles are congruent. Okay, so what if I told you that, so these are congruent. So what I'm going to do is take what they all add up to. What do they all add up to? They all add up to 180 degrees. And I'm going to subtract away the one angle I know, the 70 degrees. Can you see that would leave us with 110 degrees? And if it leaves us with 110 degrees and these two are the same, the 110 degrees I have to split equally between them. So couldn't I just divide that 110 by 2 and end up with 55 degrees for both of the angles? Right? This would be 55 degrees and this would be 55 degrees. Okay? And if you added those all up, you'd get 180 and these are the same. So the measure of angle Q is 55. And the measure of angle R is 55 degrees. Alright, number 5 gives us like this crazy drawing and asks us to find the measure of angle 1, angle 2, and angle 3. And I'm hoping you're noticing that there's really just a bunch of triangles up here. In fact, I think there are like 5 triangles. There's 3 small ones. And then if you put those two together, you get like a bigger triangle. If you put these 2 small ones, you get that bigger triangle. And basically the fact is that in any of those triangles, all 5 of them, if you add up all 3 interior angles, their measures add up to 180. So we're going to use that idea kind of over and over again to figure out some of these problems. So here's maybe where I will start. I'm going to notice that this triangle right here already has 2 angles, right? I actually have this 29 degree angle right here and this 71 degree angle. So couldn't I figure out the measure of angle 1? All I would need to do is take 71 degrees and 29 degrees and add them together. And it looks to me like I'm going to get 100 degrees. So if these are 100 degrees, how many does that leave for angle 1 if they all have to add up to 180? Well, this would end up being 80 degrees. So the measure of angle 1, 80 degrees. Alright, here's what I'm going to do next. I am maybe going to notice that if I have this angle right here, well, doesn't this make a nice straight line? And if this is 80 degrees, well, this has to be the rest of that straight line. And straight lines are half of a circle. So if this is 80, this would have to be 100 degrees. Is that right? And now I can kind of look at this triangle right here. And do you notice I have 2 angles? I got the 46 and I got the 100. So it looks to me if I add those together, I'm going to get what? 146. And I can subtract that from 180 and it will leave me with angle 2. So let's borrow. 10 minus 6 is 4. 17 minus 14 is 34 degrees. That angle is 34 degrees. Hopefully you're noticing that every time I figure something out, I add it to my picture. The more you can see, the easier geometry gets. So this would be 34 degrees. Alright, let's see if we can do one more of these. Well, here's what I'm going to do. I'm going to notice, well, if this is 100 degrees, wouldn't that be a vertical angle? And so how much would it be? Wouldn't it also be 100 degrees? And now I will look at this triangle right, let's do blue. Let's look at this triangle right here. And I have the 100 and the 44. So if I add those together, I'll get 144. I can subtract that from 180. I'm going to borrow. 10 minus 4 is 6. 17 minus 14 would be 36 degrees for this angle. I've just figured out my last angle. So the picture on the real test won't be exactly like this, but as long as you can see a linear pair or vertical angles or triangle sum theorem, you can kind of figure out any problem we might give you. Just remember, mark up your test with everything you figure out. You get one answer, it helps you figure out the next one, but it doesn't unless you write it on the picture. All right, number 6 tells us we have triangle ABE right here, and it's rotated 180 degrees, and it will form triangle CDE. So here's kind of the point that it got spun around. And they want us to name all the pairs of congruent segments and angles. So we can kind of notice if this spun around, and it would land on C, right? And that means if I have point B over here, when it got spun around, it would land on D. So we've got some places that are congruent. In other words, segment AB, if you spin that around, is going to land right there. And segment BE, if that spins around, it's going to land on ED. And this segment AE, when it gets spun around, it will right there. So there's all the congruent sides. So let's write these out, all the congruent sides. So what would that be? Segment AB is going to be congruent to segment CD. And then segment AE right there is going to be congruent to who? That's going to be congruent to EC. And finally, segment BE is going to be congruent to, that flips around all the way over to ED. All right, those are all the sides or segments. Let's talk about all the congruent angles. So here come the angles. All right, and I kind of put colored points on them to kind of help us see it. So angle A goes with angle C. And the green ones, angle B, would be congruent with angle D. Now, here's the one tricky part, and it even reminds you, take care when naming the points at E. In other words, you can't really name that angle E because there's an angle here that has a vertex E, this one, this one, this one. You can't name it angle E. You have to use 3 points. So if we're naming this one, I would call it what? Angle BEA, angle BEA. Or you could call it angle AEB. That would be totally fine. And it's congruent to, all right, this one over here, what would we call it? How about CED, angle CED? All right, and based on this rotation, if you just mark it up, it'll be easy to name the angles and segments that they're talking about. All right, here's number 7. They very simply want us to solve for x. And hopefully as soon as you see this problem, that these two sides in our triangle are congruent, hopefully will jump right out at you. You should hopefully see that this is an isosceles triangle. And as soon as you see that, I'm hoping you will say to yourself, well, then these two angles that are straight across would have to be congruent to each other. All right, they're being a little bit tricky in this problem because if you'll look right down here, they give you this side down here is 32. And if you're not careful, you'll think, well, that 32 is there, I should use it. Well, does that side have anything to do with the measure of those angles? Actually, the answer is no. Okay, so a good geometry student will notice that that 32 is kind of unrelated and will totally leave it out of the problem. All we have to do is realize that these two angles right here are congruent angles. So the 5x plus 25 degrees and the 40 degrees have to be, well, if these sides are congruent, then those angles are congruent, and that is the equation that we would write. Okay, then it's just a matter of simply solving by subtracting 25 degrees from both sides so that we get what? 5x on one side and 40, take away 25. Maybe I'll do a little bit of borrowing. So 10 minus 5 is 5, and 3 minus 2 is 1. So we get 5x is equal to 15, and when I divide both sides by 5, x is 3. And you don't use that 32 because sides don't like equal into angles. They're not connected in that way. All right, number 8 gives us this triangle. So here we have this triangle right here, and it has 3 interior angles. So there's this angle and this angle and this angle. And then if you look carefully, you should notice that right here we have an exterior angle. So here is an exterior angle right here. Okay, and that's kind of what's going on in this one. Excuse me. Okay, and it says write an equation that could be used to solve for x and give a reason for your equation. Well, do you notice these three interior angles? Well, 2x plus 18 plus 4x minus 12 plus the other angle, 2x minus 24 degrees, must equal 180. And if we had to give a reason, we would write like triangle sum theorem, right? Or the three interior angles in a triangle add to equal 180 degrees. All right, so you could write triangle sum theorem. I would accept that, or you could kind of write out what the triangle sum theorem says. All right, but that's not the only thing, because they want us to give another equation. So don't think you have to use them all, right? You notice that we didn't use the exterior angle, but if you look, this obtuse angle and this acute angle make a straight line. So just these two together, so 8x minus 36 degrees plus the interior angle that's right next to it, 2x minus 24 degrees, they add up to 180, right? This one and this one make a straight line. That's a linear pair from what we studied in like our very first unit. Don't let the rest of the triangle like get you confused. You've seen it lots of times. And I would probably simply write that like a linear pair is supplementary. And that would be a good reason. All right. Now they want us to solve for x. And here's the deal. We kind of have some choices. We could either solve this equation or we could solve this equation. Okay, we're going to get the same answer. So you can either solve the one that looks easier to solve or the one that you're absolutely sure like that one is the right one. This one down here looks a little bit smaller to me, so I'm going to solve this one. So I think I'll rewrite the equation 8x minus 36 degrees plus 2x minus 24 degrees is all equal to 180. And let's combine some like terms. So 8x and 2x would make 10x, and negative 36 and negative 24 would make what? Negative 60 is all equal to 180. If I add 60 to both sides, I will end up with 10x is equal to, let's see, 180 plus 60 comes out to be 240, and when I divide both sides by 10, x equals 24. All right, so I got my x value. The last thing they ask for is an exterior angle. Now, what if on the real test they asked for any interior angle? Well, if they did that, you could plug it in for any of these three interior angles. But in this case, they asked for the exterior angle. So the only one I should use is that one. 8 times whatever x is minus 36 degrees. And right there, I figured out what x is equal to. It's equal to 24. So if I work this out, I should get the measure of this exterior angle. Let's see, 24 times 8, that's 32. Carry my 3, that's 16 plus 3 more is 192. Now I'm going to take 192 and subtract away 36. So 12 minus 6 is 6, and 18 minus 3 is 156. There's the measure of that exterior angle right there, 156 degrees. And I'm just noticing that on my actual answer sheet, I gave you the wrong answer. So I made a little mistake on that one, but this one is right. All right, number 9 says to write a 2-column proof. And they give us some information, so the very first thing I'll do is start marking up my triangles. So segment XY and segment ZA are what? What does that symbol mean? It means that they're parallel. So please be careful, don't put tick marks on them. Segment XY and segment ZA are parallel. And then they tell me that segment YB, here's YB, is congruent to segment BZ. And they want me to prove that the two triangles are congruent, and I'm going to do some statements and reasons. Now, a few facts for you on the real test. On the real test, they won't actually have you do the whole proof. They'll do part of the proof for you, and then off to the side, they'll have like some statements and reasons that you can pick from. Okay, and some of those ones that are over there are wrong. and the right ones are there too. So you just have to go through the proof and like pick out the right ones and put them in the right spot. So it might be a little bit easier, but you also have to like ignore the ones that will be wrong. You don't use them all. So let's get ready for that by just doing the whole proof. So step one, I think I'm just going to put some of my given information in here. So I'm going to put down that segment XY is parallel to segment ZA. The reason would be given. Just so you know, there's not some like has to be a certain number of statements and reasons. You just do what's needed in order to prove what you got to prove. So next statement, I'm going to say segment YB is congruent to segment BZ, and that is also given. And actually, if I'm kind of keeping score here, this is what a pair of congruent sides. So I'm going to try to show that I have one of these. Right? Those are the three that we use, and I've got some sides. Alright, so we need some more sides and angles, and probably the next place I'm going to notice is right here. I got some vertical angles. Okay, so let's put this in my proof. Now don't call this angle B. What would it get called? Angle XBY. XBY is congruent to angle, what about this one? ZBA? Angle ZBA. And the reason is, what are they? They are vertical angles are congruent. All right, and if I went and try to keep some score, this is what another pair of congruent angles. In fact, I have a side and an angle. I could probably cross out the side, side, side. Right? I've already got an angle, and that doesn't even have any angles. All right, the next part, sometimes difficult to see. So let's see if we can do this. This is parallel to this, and this would be a transversal. So when you mark that up, it hopefully helps it start looking like all the drawings we did in our last unit, right? These are parallel, and this is a transversal. And if I were looking at this angle right here, that would be this angle right here, and then this one over here would be this one right here. So do you notice that these are alternating interior angles? Alright, so that's angle Y and angle Z, right? So I could actually say that angle Y is congruent to angle Z. And because it's the only one at point Z, I don't have to like name it with more points. You could excuse me, you could call it angle AZB. That would be fine, but you could also just call it angle Z in this case. And what would the reason be? Well, we're going to say that what are these? These are alternating interior angles. Alternating interior angles are congruent, and that gives me another pair of congruent angles. And now, when I look at just one of these triangles, I hopefully can see that I really do have angle, side, angle. I've got angle, side, angle. So statement number 5, or reason number 5, by virtue of the angle, side angle postulate, I can now say, and let's name this one. So I'm going to call it triangle, and I'm going to call it XYB. XYB. You could call it something else. You could call it angle BXY. As long as you put them in, you put them all down. Now the other triangle has to be named following the correspondence. So if I started with X, who does X match with in the other triangle? It matches with A. And then if I went to Y, from X to Y, I'd go from A to Z, and then B would be at the end. And that would be a good proof. All right, this one says name a sequence of rigid transformation that would map this one onto this one using angle, side angle. You can kind of ignore the angle, side angle in this problem. You just have to figure out how would I move this triangle over so that it would perfectly map onto this one. And I think what we're going to do is take this triangle right here and kind of see if we could move it over onto this one. Alright, so I've got this whole triangle, and what I'm going to do is I'm going to slide it over so that that point matches with that point. Okay, now you might be saying, well, that doesn't make them line up. But I have basically moved, let me get a little arrow on here. I've taken point B and I've moved it over to point L. All right. And if you kind of notice, this is the 53-degree angle. It kind of makes sense that I would move it over here because this is the 53-degree angle. So what I have to do now is I'm going to grab this one. Uh-oh. I might have a hard time actually grabbing it. And what I would do is I would spin it down. And actually I'm noticing I can't spin it down, but I would grab it right here and I would spin it around until point A over here maps onto point J. Okay, so here's this one, and I've moved it over to land on this one. Okay, so hopefully that helps you visualize what's going on. So if I were going to write this out, I map B maps on to L with a translation. Right, we just kind of slid it over there, and it was like way over here. And then I moved point A, and I then rotate point A onto J. And the whole triangles will like map onto each other. And it's called a sequence because we had to do what? We had to do a translation and we had to do a rotation. That's more than one transformation, and that's kind of what's going on here. This will be a multiple choice problem on your test, and so you can kind of just go through each one and ask yourself, would it really make the first triangle exactly line up on the second triangle? Alright, number 11 says, state the third congruent statement that must be given to prove that these two triangles are congruent. And here's the big key idea. It has to be using angle side angle. So here's what we're going to do. We are simply going to mark this stuff on our two triangles, and then we'll see what we would need to get angle side angle. So they're going to tell me that segment DF, so I'm going to mark segment DF is congruent to segment AC. In fact, maybe I'll put that that's a pair of congruent sides. And then they're going to tell me angle F, this angle here, is congruent to angle C. So those would be a pair of congruent angles. Okay, and what they want is what? Angle side angle. So we already got a side, the side's done, and we already have one of the angles. We just need this other angle. So here's the deal. Here's where students sometimes get confused. There's only two angles left, right? You could either talk about angle E and angle B, or we could talk about angle D and angle A. So one's going to give us angle side angle and one is not. And here is the big deal. To have angle side angle, your side has to be right between the two angles. So you tell me, if I chose this angle here, would that really put the side right between the two angles? Can all of you see that that does not put the side right between the two angles? So I don't want that. What I want is this angle over here. Do you see that? Angle side angle. So we want these two right here. So the answer would be angle D and angle A. Those are the ones we would need to have to get angle side angle. If we put it over here, that would be like angle side, and that's not one of the ones that we need, right? The three that work are the ones we've talked about before. How do you think this problem might change on the test? Could you imagine that instead of using angle side angle, they said like side 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 or side angle side? That's why it's important to understand the ideas and not just memorize this particular problem. That wouldn't do you any good. All these problems will change just a little bit. But like understanding like an angle has to be between two sides, that will help you out. And this technique of drawing it up on the problem, that's what's going to get you a good grade. All right, number 12. So we've got three triangles on here. I hope everyone can notice that we got this triangle right here, triangle JKL. And do you notice it's the pre-image because none of its points, none of its vertices have a prime mark? So this is one copy, and here's like a second copy, right? So it says two different transformations. So they transformed it once and then they transformed it again. And they want us to describe a single transformation that maps JKL onto J prime, K prime, L prime. So we're talking about going from the blue one to this green one right here. So what are our choices? This is either a what? Translation, or a reflection, or a rotation. So do you notice that like these are the same distance, this is the same distance, right? This is definitely a reflection. This is a reflection. And what was the reflection line? Reflection across the x-axis. Okay, so here's what I want to point out to you. If you were taking the test and you just says, oh, it's a reflection, you wouldn't get full credit. Okay, you have to be more specific. You have to tell us, if it's a reflection, you have to tell us what's the line of reflection. If you don't, we can't give you full credit. Okay, so you have to give us some details. Here would be another way to do it. You could use some coordinate notation. Now, I'm not telling you you have to do it this way in this case, but you could. And in other words, like, do you notice that this x value right here is, j is where? It's at 2, 1. And where's j prime at? It's at 2, -1, right? Do you notice the x values stay the same? And the y value went from 1 to -1. In other words, it switched to its opposite. That would be another way you could write it. And maybe if you wrote down the points, it'd be pretty easy to do. So you can do it either way, but you do have to give us some specifics. All right, so the other transformation says, describe a single transformation that maps the blue triangle onto this one over here. So now we're talking about from the blue one to this red one. All right, so what if we were looking at all of these? From blue to red, can everyone notice that that is definitely a translation, right? Definitely a translation. So the easiest way to do this would be to just pick out matching points. So j moved over to j prime. Okay, in other words, how far this way did it move? Let's count. It went 1, 2, 3, 4, 5, 6. And if it went in that direction, we all know that's an x minus 6, right? Then what happened? It went down 1. So what would that be? Well, that's a y value, and if it went down 1, it would look something like that. So the easiest way to write these two things as a coordinate notation, and that's what I would do, is to write that if you take your pre-images, they will map on. All you have to do is what? You have to take whatever that x was, subtract 6 from it, and you'll get to the new point. And whatever the y value was, you subtract 1 from it. You could also write that this was a translation, and it went what? Left 6 and down 1. But if you just said translation and didn't say anything else, we couldn't give you full credit. Okay? All right, number 13 says a pair of triangles are shown below. We have 4 pairs, and it says find all the transformation that are incorrectly stated. Okay, so we're looking for all the ones that are like not right. Okay, and that might feel a little funny to look for like the wrong answers, but that's what we're doing. So let's see, this first one, they want to know if these two triangles are an example of reflection. Like, would reflection map the one on the left exactly onto the one on the right? Well, do you see that we could kind of reflect over this line right here? Right? Would that make the two triangles exactly line up? Well, do you see this one with 1 tick mark would fold over and land on that one with 2 tick marks? So would they be mapping onto each other? No. Right? That's one of the incorrect ones. This is not an example of reflection. It looks to me like it's an example of rotation, right? Like if we rotated around that point, then they would map onto each other, but it's not an example of reflection. All right, this one says, is this a correct example of rotation? Well, let's see. If I kind of spun this around, wouldn't that, like 180 degrees, I actually think that would, yes, that would map onto itself, all right? So this is one of the ones that's incorrect. Or, excuse me, it's correct. And I guess we're kind of looking for the ones that are incorrect. Okay, this one asks, is this a correct example of translation? Well, a translation is when something like simply slides over. Does this look like an example of it just sliding over? Yes, it does. Right? That is a correct example of translation. And last one says, is this a correct example of reflection? Well, once again, if I kind of reflect it over this line, wouldn't the one with 2 tick marks, this side right here, wouldn't it kind of reflect over here? And do you see that has 1 tick mark and that has 2 tick marks? So is this a correct example of reflection? No, it looks like translation to me, so that's a big no. So I guess which one would be the ones that are incorrect? Let's see, the ones I said no to. So this is a no, and this is a no. And you just have to look at the picture and see if the translation that's being proposed is actually the one that happened. If it is, then it's a good one, and if it's not, it's a bad one. Okay? All right, number 14, they give us these 2 triangles, and they give us some information. They tell us that segment HG is congruent to segment KG. Let's mark that up. So, segment HG is congruent to segment KG. All right, so we got some congruent sides. Then they tell me angle HGJ, that would be this angle here, is congruent to angle KGJ. Well, that would be this angle right here. Okay? All right, and then they say which rigid transformation. So this is really a question about this. Which rigid transformation? Okay, so basically we've got what? Translation, we've got reflection, and we got rotation. Those are our 3 rigid motions. They're basically asking, these are congruent, like which other way besides SSS and SAS? After all, if we were proving this with like a proof, we'd have a pair of sides, a pair of angles, and isn't this reflexively another side? Do you see that we really do get side angle side? So what if we weren't doing it that way? What if we were using a rigid motion? What could get this side to map onto this side over here? Well, do you notice this is a really good example of reflection? So the answer to this is reflection, except we have to be a little bit more specific than this. For example, anytime you say something's a reflection, you have to say what line you're reflecting over. Now, most of the time we do this, it's on a coordinate plane, and we're reflecting over like the x-axis or like a y=1 line. There's no coordinate plane here, but do you notice that what we would reflect over is actually this segment right here, right? Couldn't we flip this over that segment and it would perfectly map onto this side right here? So what we're going to say is that this is reflection across, not an x-axis or something like that. What would we call this? Well, we would call it segment JG. We're reflecting across segment JG. I'll remind you that this question is a multiple choice question on the test, and all you kind of have to do is go proposed answer by proposed answer through the multiple choices, kind of eliminate the ones that don't make sense, and that should help you get the right answer. Number 15, they give us 4 transformations, and they want to know which one will actually map triangle ABC, this red one, onto triangle RST, this blue one right here. So this sounds like this is a choose all that apply problem. So there might be more than one way to do this. So here's the first question. Could I reflect over the y-axis? Now it kind of looks like that would work, right? If you look at point B right here, it's 1 unit away, and point S is 1 unit away. So if you reflected, those would map onto each other. But take a look what happens right here. You have to look at this pretty carefully. So this is 2 units away from the y-axis, point R is, but what about point C? 1, 2, 3. So if this mapped over, point C would be over here, and it wouldn't map on. So that is not one of the choices. It does not reflect across the y-axis. It wouldn't map them onto each other. Okay, but how about how about a 90-degree counterclockwise rotation about the origin? Oh, okay, so in other words, so here's the origin, And if we took triangle ABC and rotated it 90 degrees, well, a clock spins this way, so we're talking about 90 degrees. Would this actually rotate over? Well, if you go over and down and then you rotate that 90 degrees, it would be like that, so that would map onto it. What about point A over here? It's over and down. That's what? 4 by 2. And what if we drop that down? It would be down 4 and over 2. Oh, look. That maps on as well. And how about point C? It's over 3 and down 4. And what if you spun that? It would be down 3 and over 4. Oh, they all map on. That's good. Okay, how about a reflection across the x equals 2 line? Well, the x equals 2 line would be about right here. Do you think if you jump that red one across that, well, it would be like way over here, right? So that's not right. And what about a 270 degree clockwise? So that would be 90. This would be 180. And this would be 270. And if the 90 degree one would work, can you see that these are basically opposites of each other? So that one would be good as well. Okay, so you hopefully notice marking it up helped you to see, and I would just go through each transformation and look at more than one point, because if you just looked at one point, you might think reflection across the y-axis would work. Alright, number 16 gives us a pair of triangles. And we're going to try to prove this right here, that the triangles are congruent. And they want to know which of the 3 ways that are possible is really the right way to do this. So obviously we should take this given information and mark it on the triangle. So let's see, segment BD, that would be this one, is congruent to segment BC. And we're not even doing a proof, so I'm just going to write on that that's 2 congruent sides. And next they tell me that angle D, that's this one right here, is congruent to angle C. That's a pair of congruent angles. So far I have an angle and a side. In fact, I'm noticing since I have an angle, it's probably not this one, right? It's going to be one of these two. So is there any? Well, they didn't give us any parallel lines, but hopefully by this time in the year, you can see vertical angles, no problem. And what we have are 2 vertical angles right there. So that would give me another pair of angles. Now be careful. You should only look at one triangle when you try to decide. And do you notice we have an angle, a side, and an angle? So it would be angle, side, angle. And basically if I were to explain why, we're not doing a proof, but we would say something like, well, at point B, there are vertical angles. And I might be say angle, let's see, what would that one be called? ABD is congruent to angle, what would this one be? CBE, angle CBE. And that gives us a second angle, second pair of congruent angles around the sides. Okay, so that's how we got our angle, side angle. All right, number 17 gives us 2 triangles. They give us some facts about some of the sides. In fact, I hope you notice that like segment GI and segment TS are the same length. That would make them congruent. Angle H is 62 degrees. Angle R is 62 degrees. All right, and these 4 guys, who are they? John makes a comment about the 2 triangles. These are all geometry students, I guess. Maybe you noticed that they're the names of the Beatles just for fun. But anyway, John says that these 2 triangles are congruent using side, side, side. Paul says they're congruent because of side, angle, side. George says they're congruent because of angle, side, angle. And Ringo says they're congruent because of side, side, angle. And we have to say who's right and who's wrong. Okay? All right, so here's what we're going to notice. Well, If GI and TS are both congruent, wouldn't that give us a pair of congruent sides? And if GH and TR are both 13, that would give us a pair of congruent sides. And finally, if these angles are congruent, that would give us a pair of congruent angles. All right? So that's what we end up with. Okay, and what I would like you to notice, don't we have two sides and one angle? So doesn't it seem it's like either this one or this one, because two sides and one angle, those are the only ones with two sides and one angle. So maybe we'll start there. So is this side angle side? Well, I hope you remember that like side angle side is called that for a reason. To use this, the angle has to be between the two sides. In other words, it has to be the included side. Or excuse me, the included angle is what we like to call it. So is this angle right here, right between the two sides? Can you see that this should be the angle that's right between the two sides? In other words, this is not side angle side. Okay, so we're going to write that. He's wrong because the angle is not between the two sides. Okay, so he's wrong. Okay. By the way, I want to remind you maybe, if you're taking the test and the test says that somebody's wrong, we never lie to you on the test. So don't be like, hey, actually he's right. If it's wrong, and you have to explain why it's wrong. If you say, oh, actually he's right, you just got that one wrong. So don't do that. We never trick you like that on the test. Okay, so let's do this one. Ringo says it's congruent because of side-side angle. Now, this actually is side-side angle, but here's what you have to realize. Which three shortcuts, or criterion, that's their fancy word for it, actually work to prove triangles congruent? Well, they're side-side side, side angle side, and angle side angle. Is there even such a thing as side-side angle? No, that doesn't exist. I mean, you can put any letters you want, but this would not prove the triangles are congruent. Your teacher might have even talked to you about this one, angle, angle, angle. That also, you can have three congruent angles in both triangles, but they can still be different. So these two don't work. So maybe what shall I say for Ringo? Side-side angle does not prove, like make for sure, prove that triangles are congruent. So that would never be an answer. If you saw that, you would know it's a trick answer. There's no such thing as side-side angle. Okay? And how about side-side side? Well, that I guess I should have written what? He's wrong because, right? You have to say why they're right or wrong, and I should kind of point out he's wrong. Okay, so how about John up here? Is John right because it's side, side, side? Well, do you notice we don't know anything about this side? So it's not side, side, side. He's wrong because we only have two sides. Not three. Okay, and how about George? What does George say? George says that it's because of angle, side, angle. Well, can you see we only have one angle? We don't have two that's needed. So is he right? No, he's wrong. He's wrong. I guess don't trust the Beatles to do your geometry for you. They're all wrong. He's wrong because we only have one angle, and angle, side, angle needs two. In fact, it needs the side to be right between the two angles. But anyway, we don't even have two angles. Okay, so actually, there's no reason. Now, where would this angle need to be if we wanted to get side angle side? Do you realize we would need this angle over here, and then it really would be side angle side? So that's something to think about. All right, thank you for watching this video. Remember, you can go back and go over any problems that you still feel you need help on, and I'll wish you good luck. Hopefully watching this video gives you a better chance of getting a great grade on the test.